welcome to this session. I'm Martino, and today I'm going to talk about how to build spatial and location-aware apps using ArcGIS maps and Flutter. So here's the agenda of today. First, we are going to see what are geotriggers, and I'm going to walk you through some problems we have with current location applications, and then I'm going to show and demo what we are going to build, and we are going to see few things like essential component to use for location-aware applications, and we're going to set the foundation, talk about how to create and display routes, load geographic zones, setting up geotrigger monitoring, handle geotrigger events, starting the void guidance, and yeah, I'm gonna do some little coding, and yeah, that'll be it for today. So first, what are the geotriggers? So in order to answer that, we are going to see some classic problems we have with location applications currently. So most location applications today are reactive. And by reactive, I mean, let's say I have a flow, right? So the user opens the app, and he searches for a coffee near him. So he's going to get a list and pick one. That's the first flow. The second flow is like the user manually checks in. He checks in the location. So he manually checks in the location. He shares the location with some friends and hopes they see the location. And the third flow is like user wanted to read a static map. So he tried to orient himself, and then he still get lost. So these are current, I would say, things that we have with our location app. Now, with geotriggers, we can create proactive location applications. And by that, I mean, instead of asking, where am I and what's nearby, the app automatically tells you where you are. So it's gonna, for example, you're gonna say, you're entering this specific area. And yeah, this is what is happening there. So that's what we talk about when we talk about proactive applications. Instead of us or the user asking where he is, we are going to tell him exactly where he is without him asking it. So geotriggers are location-based notifications that are fired when users enter or exit specific geographic areas. And you can think of them as invisible fences, like boundaries or perimeters around real-world location that triggers actions in your app. And why do they matter? Because first, they are automatic. User doesn't need to make any interaction with the app. They are contextual, so you can have the right information at the right time. They're very efficient though. So hardware accelerated and battery friendly. And you can scale them, with hundreds of zones automatically. So today, we are going to kind of build, I would say, a tourism application for someone wanting to go from Union Square to Times Square. And the whole idea is to make it proactive, like I said. So user will automatically get notifications about the area he is and what he can do in that zone. And we're going to add also some void guidance using the Flutter TTS package. And all these with the ArcGIS Maps SDK for Flutter. Yeah, so few requirements. In order to use or build location-aware applications, I recommend using the ArcGIS Maps SDK because that's what we're mainly going to use here. And for that, you need to have an API key. And yeah, the documentation for ArcGIS Maps SDK provide all these, so you can look for it on Google and definitely find it. Yeah, so let's see three essential components. Three essential components in order to build location-aware applications. So first, we need a location feed. And the location feed tells you where you are, tells the user where he is. So for that one, we will need a system location data source or a simulated location data source. So these are data sources that will be used to get a location, the current location of the user. So for production applications, you definitely need the system location data source. And for demos like this, we can use the simulated location data source. That's what we're going to use. But I'm going to walk you through also how you can define a system location data source for production app. And now, after having that, you can pass it to the location geotrigger feeds class. And yeah, this is going to be the element that tells the user where it is. And the second thing is what area matters. So for that, you will need the fence parameters. And here's how you define it. So we have mainly, in our case, we have two different type of zone we want to represent. So we have points and also areas. So for areas, we will need the fence Geotriggers class and pass it, I would say, what we call the buffer distance. So the buffer distance is going to define the zone. And this is in Meta, so you can define it and it will take automatically a cost. So let's say I want to trigger a notification when user approaches, let's say an object. And the area I want to define is 2 meters. So I can use the buffer distance to do that. And the third point is the rule types. So this will tell the app when to trigger the defense. So here, we have 3 rule types. The first one makes sure the notification triggers when user enter a zone. So these are all enums, so it's called fence rule type .enter. The second one is for when user is exiting a zone. So this one you can use the fence rule type .exit. And the third one is enter or exit. So for this one, it can trigger when the user is entering a zone or when user is exiting a zone. And for our case, this is what we're going to use. Yeah, so let's see some foundations. Yeah, so right now, I'm going to talk about the geometry types. So we have 3 geometry types. So the first one is a point, so a point of interest. So we don't want a zone, but we want a specific point. Let's say a specific location. So to define that, we are going to use the ArcGIS point class. And you can use it for coffee shop, entrances, and other specific location. The second type we need, we want to explore is the polyline type. So this is one-dimensional. So you can see like a route. So this is one-dimensional. And if you want to define it, you will use the polyline builder class from the ArcGIS Maps SDK. And the third type is the polygon. So it's like a geometry. Yeah, so 3-dimensional from triangle to any type of object you want to represent. Now, let's talk about the data architecture decisions. So we have the in-memory architecture. So this one is called the feature collection table. And for that one, if you want to use it, you don't need a server, so you can directly use it. And it's perfect for demos like this. And yeah, the inconvenience for that is you can have like any asynchronous data coming in. So you have to define everything in the app. The second one is one for the production apps. So you have your service online. And then you can use it to get like all the data required. So if you want to get a point, zones, and everything, you can define everything on ArcGIS online services, and then kind of retrieve it in the app, and yeah, do whatever you want to do with it. And it's real time as well. And the third one is the location database, the geo database, and this is fully offline, support offline mode. So yeah, if you want to get like data and show it to the user offline, you can definitely use it. And I'm gonna show you all this in the demo so you can see actually how it works as a code perspective. Yeah. Now, let's talk about how you can initialize the location with the ArcGIS Maps SDK. So first of all, you will need a controller, right? So to define it, you use the ArcGIS Maps view that create controller. So it's gonna give you the controller that actually gonna control everything from the location, the point, and everything. If you want to add something specific, like let's say graphics, geometries to the app, the controller is gonna handle all of this. And of course, you need a location data source that we previously defined. So whether you want to use the system location data source or maybe the simulated location data source for demos like this. Yeah, so you will need an initial position and a destination position. Yeah, so when you are building a demo or you exactly know the initial position, you can directly pass it. So it takes the point, the ArcGIS point class, and you can pass it, the coordinates, the X and Y. And you can add also a special reference. Now, in case you want to, you have a production app and you want to get the user's current location and use it as an initial position, I'll show you how to do that. Yeah, so for that one, you'll need to start, I would say, a stream. So you will define a stream subscription that will kind of notify the app of user's current position, and then use that to, I would say, to pass it to the initial destination, initial position. So as you can see, for the track location position, I have my location subscription, which is a stream. That's it defined, and it takes is actually listening to the location change. And every time the location is changed, it updates now the position, the initial position. So yeah, now you can also track like all these points. So you can have like a list. In my case, I have a list of ArcGIS points. So you can have this list and use it now to kind of, I would say, have a route, create a route on your map. Yeah, now here is how you can define, or you can display a map. So let's say you already have, the location set up, and you are also listening to the user current location, and you're updating the initial position every single time. So after that, you need to actually display, you want to display the app to the user. So for that one, you will use the ArcGIS map view widget. And when you use it, you can pass it now the controller. And when you get the controller, then it displays. Now we also have the on map view ready function, and this will actually do some basics things, from the startup of the map. So yeah, if you want to define something or you want to do a specific operation, you can do it there. So as you can see, we have this function on map view ready, and you can set up like a base map style for the app. So the base map style is like what you, the kind of map style that you want. So you can have the ArcGIS navigation. You can have also the satellite imageries and many other base maps. I will show you how it works in the demo. Yeah. And you can define also a viewpoint, like an initial position for your map. So yeah. Yeah. Now let's see how you can create and display routes. So we've talked about how to display map. Now how you define or display a route. Yeah. So when you want to display a route, you will use the route task, which is a class, and it will take the ArcGIS word routing service as a parameter. So when you get it there, now you have like the road service, and then you can use it to kind of place these roads on your map. So it's very simple like that. You have some default parameters, and you can, later on decide to update these parameters. But yeah, after that you can set like stops. So stops are mainly your initial and destination location. So you already define it, so you can pass it directly through the road parameters and set the stops. And then you will have to solve the routes and display the routes. I will show next what the display routes function looks like. Yep. So when you want to display a route, you will need to understand what we call the symbols, right? So symbols are visual representation that display geographic features on maps, and they translate data into understandable visual elements. And each symbol type corresponds to a different geometry type. So we have different symbols. We have the point, the lines, the polygons, and so and so forth. So for an example, you can use the point symbols to represent a point of interest. Like with the ArcGIS point class that we'll be using. You can also use it for markers and so forth. And there is a flexible customization also for these symbols. You can use the line symbols for routes, boundaries, and paths, and the polygon symbol for areas, regions, and the zones. Yeah, so for the display route function, that's how it looks like. So it takes the ArcGIS routes as a parameter, and you will have to define what we call the graphics overlay. And the graphic overlay is going to create like a distinctive route line symbols, for all the places you want to go. So now we have different classes. For like, let's say for the line, you have the simple line symbol class, and it takes you can customize it, like adding the color, the width, and many other things. So once you're done with the customization, you need to add now the overlays to the controller, because the controller is responsible for displaying everything on top of your map. Yeah. Now we're going to talk about how to load geographic zone. Sorry. Yeah. So in our case, since we are doing a simulation, we are going to define these zones by ourselves. But in production app, like we said, you can use the ArcGIS online services, and when you use it, you need to kind of define everything there. So when you call that service, you won't need to define any specific zone in your app, because they are all real time and coming from the online services. Yep. So now after doing that, you will need to create a rich feature table. So for feature tables, we have different fields. So we have tests, we have double, we have integers, and so forth. So you can use tests for names, messages, and test a type. For example, let's say you define, you want to define critical, types, like critical points, and you have different categories for your points. You can do it with the test fields. And you can use the double fields to display like the customize the radius of your app. Like let's say buffer zones, you can use it to do that. So when you want to create a feature collection table, or a zone, you will use the feature collection table class. And when you use it, you will pass it like the fields you already defined using the JSON, or like the area that we already saw. And after that, you will define like the geometry type. So is it polygon or polyline and so forth. And add it also a special reference. Now after that, you can now create like the zone. So on the second snippet, you can see how I create a zone, and this is for circular zone. I'll show the code later on, and you can see how it looks like. Yeah, so for this, when you want to create like a circular zone, you will have the center, and define like a buffer around the center. So this is for circular zones, but we have different type of geometries, like I said. So you can define like a zone which is triangular or rectangular or so forth. It depends on the customization that you want. Yeah, and next you need to define a geotrigger monitor. So this is actually, you know, the root of the whole thing, because this is going to help you to monitor like everything that is happening on the map, and then trigger messages or text when it's needed. So here is, you know, how to set it up. You need to you already define like the location geotrigger feed. So since you have it already, now you are going to use the fence geotrigger and get like define also what we call the message expression or the arcade expression. So the arcade expressions is what is going to handle the message for the geotriggers. So when you want to monitor the geotrigger, you monitor actually the fences, the area or the zones. And every time that you're listening to the geotrigger, then you can, you know, fire the event that you want. So you can check like whether the user is exiting a zone or entering another one. So all these things can be done with the geotrigger monitor. Now for the geotrigger events, now like we saw before, we have you know, different fence rule types, right? We have the enter, the exit, and enter exit. So now here specifically, we will see how to handle the geotrigger event. So you have your zone already, and you have also the notification info that you got from the geotrigger monitor. So when you have the info, now you can check like, is my user entering this specific zone? If yes, then send this notification. Is my user exiting this zone? If yes, send the notification. So when we talk about notification, it doesn't mean especially that you have to create like, use like a notification you know, package, but we're talking about a message that you're receiving and what you're doing with the message. Yeah, and yeah, since you already have like all these elements, now you can you know, start your voice guidance. So the voice guidance is like, oh yeah, I have my message. I want to, how will the user know, you know, that he is entering a zone? So we need a third-party library. So here we will be using the Flutter TTS. But if you're familiar with another, you know, text-to-speech package, you feel free. You can feel free to use it. So for the voice guidance, and especially for the Flutter TTS package, there is a specific iOS you know, configuration to do if you want to run it on real real devices, like real iPhone devices. So this is how it works. If you don't do it, it will definitely not gonna play on real devices. Yeah. So I'm gonna go walk you through the app and show you like all these things, and yeah. So here is the app. Here is the app. The code is here. I'm going to directly run it. Try to. Yep. So like I said, the demo talks about, you know, one user living like the Union Square and trying to go to Times Square. So I have some configuration variables here. So I have the driving speed. I define the driving speed, the point of interest buffer distance, you know, the zones, and also the initial zoom scale. And like I showed you, you will need like a start location and a destination location. So for me, since I'm using the simulated location data source for the demo, that's why I defined these values, like I said. And especially for this demo, I created, some raw data for the navigation. So what you see in here, these are like specific point the user is going to, walk through. So we have it here, and there are zones already. Like we have it's starting from the Union Square. So this is the first zone. I define also the radius of the zone, the perimeter, and yeah, then we have the Fluttercon district and so on and so forth. So we are using this, but in a production app, you'll use the ArcGIS online services, like I said. So you won't need to kind of do all these customizations in the app. And the point of interest, like we're talking about it, these are points that will be set on a specific location in the app. So all of these are defined. And next, I'm showing the tour screen. So it's a bit long, but yeah. First, I have the location service that I defined. So I'm using the simulated location data source. I'm getting the current speed from the demo config. And yeah, I'm initializing the data source. And now the driving path that I already defined, I'm kind of building a polyline, with them like this. So I have the path builder that I'm adding point to, and I'm getting the point from my driving path list that I showed. So when we run it, here you can see I made sure to define like speed for my demo, so I can customize the speed, and it's reflecting directly here. And the initial demo status is like ready for NYC tourism demo. Press start demo to begin driving, and this is a real time with the voice. So when I click on play,
starting at Union Square, historic gathering place and farmers market.
I think the mic. Let me see.
Passing through Flatiron District, famous triangular building nearby.
So I'm gonna restart, and yep. Yep. So my initial location is the Union Square. So I'm not sure if it's showing correctly, but you can see the test. So the Union Square test. This is also a symbol that I represented, which is the point, and have the buffer around it. So when it starts,
starting at Union Square, historic gathering place and farmers market.
Yep. So you can see that we having like a description or like a message playing describing the place. So these are all set, by us in the app.
Resuming demo. You are in Union Square.
Yep, it's pretty slow. The speed is 4. I'm gonna let me restart and do it again. Yeah, so I will increase the speed and.
Starting at Union Square,
yep,
historic gathering place and farmers market. Passing through Flatiron District. Famous triangular building nearby.
Yep. So notice how it's describing the places, and once you entering or you trying to enter the zone, then you start seeing the messages.
Resuming demo. You are in Flatiron District. Major shopping district and Macy's flagship store.
Yep. So here too, we have the message, but this is a point, right? This is a point. So it's not entering an area, but it's actually describing the point.
Continuing the tour. Heart of Broadway. Famous theaters and shows all around. Heart of Broadway with world-famous shows.
So another thing again, you can have a zone and have point or location inside a zone. That's why we say you can define as much as zone or point as possible.
Resuming demo. You are in Theater District. Approaching Central Park, the green heart of Manhattan.
So when I pause it, I can resume it.
Continuing the tour. Columbus Circle, gateway to Central Park and Upper West Side.
So every time you can notice on the top left, you can notice the area there.
Arrived at Times Square, the crossroads of the world. Famous demo tour completed. Click Start Demo to tour again.
Yep. So it's all guided by voice, and that's what we're really talking about here. So I can try to I will try to make some changes, and you'll see how it will reflect. So the first thing I'm going to do is to try to change the base map style. So here we have, we're using the ArcGIS navigation base map, but we can try like the satellite the imagery one. So let's use this base map. So I will have to restart. Yep. So this is satellite base map style, and I can add like tons of base maps as I want. Yep. So that's the first thing. And we can also change this a little bit, try to add like a point of interest also here, like somewhere around. So for that, I'm going to the demo configs, and I can do one thing. Instead, I can change like this name. Let's say instead of square, I would say initial location. And I will restart again. Oh yeah, this is gray. But you can see the change has reflected, but probably the style of the map, it doesn't really allow. So what I would do is I will reduce the radius. So we have initially, we have this radius. I'll change it to 50. So you can see initially we have the buffer, right, the zone, which has reduced the boundaries. I'll bring back my navigation base map. Yeah. So the size or the buffer has reduced, and all this info right there, I can customize it. So maybe the message can change it to initial location. And when the voice starts again, see?
Initial location.
Yep, so it's no longer Union Square, but it's initial location. So all these things, like I said, I'm doing it locally, but when you are running a production app, you can do all this on the ArcGIS online services and use them now directly, in the app. So mainly, that's it. So back again. Yep, so here are some key takeaways from today's presentation. So first thing, what you need to know is when you want to build a proactive location application, you will need geofencing or geotriggers, right? And this will allow you to build smart, contextual application. And one way you can better take advantage of this feature is by using the ArcGIS Maps SDK for Flutter, which is a powerful stack for your GIS applications. So, of course, we have some useful links. So, I have the demo on my GitHub already. So I can show you. I didn't add a link directly, but yeah, you can go to my GitHub, Martino Yovo, and you can find the code. So you can also play around it. And of course, other so the package itself is here. So you can go try it out. We have also the sample viewer app, which actually is like a portfolio of all the possible features you can have with the ArcGIS Maps SDK for Flutter. And you can also go to the developers.arcgis.com/Flutter and see like the actual documentation and how things work. And I wrote also a blog on how to build location-aware applications with Geotriggers, so you can check it out as well. And yeah, we have also a strong community at Esri, so make sure to take a look and you can see like users' requests and everything there. All right, thank you for attending. That's the end of my presentation. If you have any question, feel free to ask.